Okay, time to look at question 3. Make sure you've attempted it first. The first question is going to be a calculation. So we've got some numbers. So we've got 30 watts. So watts unit is going to be power. We have got it's using 600 joules of electrical energy. So it's going to be an energy. In that time, in a certain time. So we're going to be asked for time at some point. In that time, it produces 450 joules of light energy. The rest of the energy is wasted. So that's going to be our input energy. And that's going to be, that's not the wasted, that's going to be our useful output. So calculate the wasted energy. All right, nice easy one for us to start off with. So, if it uses 600 and it's going to produce 450, the rest is going to be wasted. Now, even with the most straightforward of calculations, I still suggest you use a calculator just in case. 600 minus 450, you've got it in the exam, why wouldn't you use it? 150 joules. So 150, pressing things on the calculator there. What happens to the energy wasted by the bulb? Well, it's going to be transferred to the surroundings as heat. Calculate the efficiency of this light bulb. So we've got actually 2 marks here, so there's actually something to do. The one line makes it look like there's less to do than is. So we want to calculate efficiency. So let's have a look what we've got. So it wants an efficiency. We have got a power, we've got an input energy, and we've got a useful energy. Let's just get rid of this for a second and let's get to our data sheet. So we've got, looking for efficiency, we've got input energy, useful energy, and a power. So here's our data sheet. We're just going to scan through until we find the word efficiency. All right, there are 2 equations with efficiency on. Useful output energy divided by total input energy, useful output power, total power. So we are going to be wanting this top one because the top one has got our energies in it. So it's useful output energy divided by total input energy. Back to this. So FIFA, we can do this down the side. So efficiency equals useful. Just check that. Useful output divided by total input. If we input our data, we get efficiency is equal to the useful output, which is 450. And we're going to divide that by our total input, which is 600. Let's grab our calculator back. There's no rearranging to do. There is no converting to do. So we are just looking for 450 over 600. And we get 0.75. Make sure you are showing this working out here. Alright, because it's going to get you the credit if you, for some reason, don't put the efficiency in. And efficiency is always a percentage. So we're going to get that, we're going to multiply it by 100, which we can do. Oh, make sure you don't do that. Make sure you get the answer first, and then you multiply the answer by 100, which is going to give us 75%. You would be allowed 0.75 as an answer, but 75% is okay as well. Let's give it over. So calculate the period of time. Another calculation. So time during which the 600 joules is provided to the 30-watt light bulb. So we can start to annotate this up. So we've got a time, we've got an energy, and we have got a power. And the subject is going to be the time. So let's choose our formula that we want. So F for formula, we're going to go to this data sheet. We've got time, energy, and power, and we want time. So, oh, there's one straight away, look. Power is energy transferred divided by time. That would work. The problem with this one is that time is on the bottom of the fraction, which is fine. It's just a bit more complicated in terms of rearranging. So I'm going to see if there's another one where the time isn't in the fraction. So let's have a look, because I think there is. There you go, look. Energy transferred equals power times time. And that's much easier to rearrange. And it's got the same things in. So energy is equal to power times time. Energy equals power times by time. Right, let's input our data. Energy, so we've got 600 is equal to the power, so 30 times by our time. All right, we want to make time the subject, so we're going to do the inverse. It's currently being times by 30, so we are going to divide by 30. So this is our fine-tuning. Divide this side by 30. So we should end up with 600 divided by 30 is going to be equal to time as the subject. So 600 divided by 30. Gives us 20 seconds. That makes sense. Right. A company that makes light bulbs provides information about some of their products. So we've just got a table here. There's going to be stuff to do. So we've got 3 columns. Make sure you use as many of them as possible. Suggest what is important to confirm information independently. All right, this is just a standard how science works question. So you might have come across this in the biology paper where they talk about drugs companies, doing research on their own products. They're always going to say that their products are the best, and they're going to want that finding. And it's going to be exactly the same idea here with this light bulb manufacturer. They're going to find that theirs is the best product. So the whole point of comparing information is to avoid bias. If you give a bias idea, you're saying, there's a reason why you would suggest it that isn't necessarily to do with you're looking for a specific outcome. Ooh, another calculation. So a homeowner is thinking about replacing filament bulbs with LED bulbs. A 12-watt LED bulb gives the same amount of light input as a 60-watt filament bulb. It's not a calculation. Suggest reasons why the homeowner is likely to choose LED bulbs. 2 marks. We need 2 reasons going on there, and we need to use information from the table. So we can't just say things from our knowledge. We have to use this information. So let's have a look. So why would we want? Why is the LED better than the 60-watt filament? Well, first off, the lifetime in hours is more for the LED, and also it's going to use less power. So if it's going to use less power, it's going to be using less input energy. So we can call that reason 1. So the LED uses less power. Brackets. Why is that good? It's because it's going to reduce energy usage and last longer. So there's the first point. I know there's 2 points in there. But the reason why I'm classing that as 1 is because I've got this whole column here on cost, and they wouldn't have put that in there if they didn't want me to use it. So I'm going to have to use that column. Right, the second mark's the trickier one. We've got the cost of the bulb, and on the face of it, it looks like the LED bulb costs £16 for one bulb, whereas a filament bulb only costs £2. So it looks as though, we'd be better off buying filament bulbs. However, because that lifetime is 50,000 hours as opposed to the 1,250 hours for the filament bulb, I would be interested in looking at how much it actually costs in comparison. So let's figure out how many filament bulbs we would need to get the same amount of hours as one LED bulb. So if we're just going to write it down here. So the LED bulb is 50,000 hours, whereas the filament bulb is 1,250. So if we divide that, we'll figure out how many bulbs, how often we would have to replace that bulb to get the same amount as one LED. So we'll do 50,000. I'll divide that by 1,250. So 40. So that means that we would have to use 40 filament bulbs for every one LED bulb. Okay, so would need to replace the filament bulb 40 times to get the same lifetime as one LED. All right, and we've got a cost on this. Let's figure out how much that would cost. So one LED is £16. I don't know why I did that. £16. Whereas our 40 times, well, we've got, so each one is £2. We've got 2 times 40, which is 80 quid. So £80. So we would have to replace the filament bulb 40 times, which is going to be £80 to get the same lifetime as one LED bulb, which is £16. So cost lifetime of the LED is less. Okay. So one factor other than efficiency that is important when considering the choice of bulb for lighting in the home. All right, so we can't talk about anything from the table. We're just going to use our knowledge of filament bulbs here and LEDs. Well, I have LEDs in my house, and the whole point of an LED is that it wastes less energy, so less energy is converted into heat. So therefore, the bulb, so the LED bulb will be lower less chance of burning yourself if you touch it. Well, that's a general reason. I suppose the other one you could have had is you could have said that the LEDs come in a lot of different sort of tones of colour. I know that we have LEDs in our kitchen where we want that sort of bright clinical service, and we have those really cold, so it's called like a cold colour. It's very white. Whereas in our living room we use the LEDs which are warmer, which is it just gives it a lot of a nicer colour of LED. So you can get the availability in different colours of LEDs, whereas with a filament light you can't do that. Okay, that is the end of that question. Join me for the next one.